Their mission? To enforce a delicate political agreement, hoping to bring an end to the most protracted and bloody conflict Europe has seen since the Second World War. Armed to the teeth with the latest in high-tech weaponry, these combat warplanes are a sobering reminder of the striking force of modern air power. The high cost of air power means that today's air forces have to be very careful about the number and type of aircraft they purchase. With commitments around the globe, the U.S. Air Force requires a sizable fighter force. Today it has almost 90 tactical fighter squadrons with nearly 1,500 fighters. Two fighters have formed the backbone of these fighter squadrons, the F-15 Eagle and the F-16 Fighting Falcon. Both aircraft were designed in the 1970s, and both matured into their current variants during the 1980s. As a result of its sheer size, the U.S. Air Force decided to buy a mixed fighter force of F-15s and F-16s as the best balance of economy and capability. The F-16 sits at the low end of this high-low mix. It is a much smaller aircraft than the F-15, and also much less costly. The reasons for this are immediately apparent. The F-16 is powered by a single jet engine. The F-15 has two. This reduces the original purchase cost and makes it cheaper to operate. But this should not be misunderstood to mean that the F-16 is a low-performance aircraft. To the contrary, the F-16 has a formidable combat record in the air battles over Lebanon, over Iraq, and in a series of small wars and border incidents around the globe. The single-seat F-16 is the essential fighter, adaptable to a wide range of missions and a wide range of weapons.
The F-16 gives you more bang for the buck than probably any airplane on the market. It will carry almost any form of ordnance you want to hang on it. You punch it all off, you've got a great dogfighter, you hang it all on, maybe you can drop some bombs or attack a ground target. So for the amount of money you put into it, you have an enormous amount of capability, whereas most nations really can't afford the larger fighters we fly, like the F-14 or the F-15.
This versatility means that the F-16 can be used for many different types of air combat. In its basic fighter role, the F-16 is armed with the latest missiles. On its outer wingtips is the world's most sophisticated air-to-air missile, the AMRAAM, designed to give the F-16 the upper hand in a dogfight with any other fighter. Past generations of radar-guided missiles depended on the fighter aircraft to guide them to the target. The fighter's radar was aimed at the enemy fighter, and the missile honed in on this electronic signal. But this meant that the fighter could not maneuver while the missile was still in flight, leaving it vulnerable to attack. And it could only attack one enemy target at a time. The AMRAAM was designed to allow the pilot to turn off the fighter's radar and still engage targets. This protects the fighter from being detected from its own radar and then targeted by an enemy's air-to-air anti-radiation missiles. While still very far away, the fighter locates the enemy with its radar and can turn the radar off. The pilot then feeds the target coordinates from the fighter's computer into the missile computer. The missile locks on and the fighter launches the missile. The fighter can then turn as much as 40 to 50 degrees off the target, periodically turning its radar back on, relocating or painting the enemy fighter, then downloading the data to the missile while it heads to the target. 12 miles from the enemy, the missile's own radar turns on and locks on for final guidance. The missile impacts while the fighter is already preparing to launch another missile at a second enemy aircraft. The F-16's versatility makes it ideal for the strike fighter mission. It can attack targets in the air and on the ground. Operation Desert Storm demonstrated the effectiveness of new fighters outfitted with the latest strike weapons, precision-guided munitions, and smart bombs. Newer versions of the F-16 are fitted with the advanced Lantern night attack system, allowing the F-16 to attack targets at night or in bad weather conditions.
This targeting pod has two functions it gives us. One is it turns basically night into day. It gives us a IR image up in the cockpit of the target area we're looking at. So I can get, even when it's pitch black outside, I can get almost what looks like a day image, but it's in the IR spectrum of the target area, and that will help me then to guide bombs in. The second thing it does is there's a laser. And so I can fire a laser, and then my bombs can follow the laser spot on down to the target.
The Bosnian peacekeeping missions put the versatility of the F-16 to the test. Unlike outright warfare, peacekeeping missions are difficult to plan. The fighters may be attacked by enemy fighters, or they may be called on to carry out a mission against ground targets. So these F-16s are equipped with a remarkable array of weapons to cover all contingencies. They are armed with AMRAAM missiles for dogfighting on their outer wing pylons. Under the wings are Maverick ground attack missiles, HARM anti-radar missiles, or bombs. The epitome of modern interceptor aircraft is the F-15 Eagle. While the F-16 was designed for a multiplicity of missions, the F-15 is a specialist in air-to-air combat. It is much larger than the F-16 in order to carry a bigger and more powerful radar, as well as a heavier missile payload. It has one primary mission: attaining air superiority over the enemy air force. It accomplishes this mission with a full range of missiles, including the short-range Sidewinder, the medium-range Sparrow, and the beyond visual range AMRAAM. The F-15 has greater range, greater payload, greater speed, and a much more powerful radar than the F-16. But these features come at a price. While an F-16 costs about $18 million, the F-15 is nearly double that cost, about $35 million. For years, the U.S. Air Force's main all-weather attack aircraft has been the F-111. But the F-111 is old, with some of the fleet in service for almost 30 years. Instead of designing a whole new fighter to replace the 111, the Air Force decided to adapt the F-15 to this role. The result is the F-15E Strike Eagle, which, unlike the single-seat fighter version, is a two-seater. In the backseat is the weapons officer, whose task is to navigate to the targeted area and then aim the precision-guided attack weapons against the targets. The Strike Eagle can also perform as a fighter plane, but its specialty is to attack pinpoint ground targets in any type of weather. Because it has longer range and a larger ordnance payload than the F-16, the F-15 is used as a deep strike aircraft, able to attack targets deep into enemy territory. The Navy follows the Air Force pattern almost exactly, with two fighter types, the Hornet and the Tomcat. The Hornet is the Navy's equivalent of the F-16. It is officially codenamed the FA-18, the F standing for fighter, and the A standing for attack. Like the F-16, it is a jack of all trades, equally effective for fighter missions or ground attack.
You can't fill an entire carrier with aircraft the size of an F-14. It's just not affordable. For that reason, the Navy has gone to a smaller multi-role aircraft that can swing between air defense and strike missions, the F-18 Hornet.
Navy aircraft operate in an environment which calls for much more durable and expensive aircraft than the Air Force needs. For example, the Navy's Hornet has two engines compared to the Air Force's F-16's single engine. The reason is simple. Navy aircraft operate far out at sea, and if a single-engine airplane suffers an engine problem, it has no hope of making it back to the carrier. But if a twin-engine plane like the Hornet loses an engine, it can make it back to the carrier on just its remaining engine. The Hornet also has to survive the stress of carrier launches and landings. The catapult launches take a heavy toll on its delicate electronics. And carrier landings are often described as controlled crashes, with 18-ton aircraft slamming onto the deck of a ship at speeds well over 100 miles per hour and going from 125 miles an hour to zero in a matter of seconds. Needless to say, such enormous forces require an exceptionally rugged airframe. This ruggedness comes at a high cost, a cost that land-based air forces are seldom willing to pay. The Navy's Hornet is about 50% more expensive than its Air Force counterpart, the F-16, with a base cost of about $25 million. The Hornet's stablemate on a carrier is the legendary F-14 Tomcat. The Tomcat, like the F-15, was designed for one mission only: air superiority. But air superiority over the ocean means something different than air superiority over land. For many years, the main opponent of the Tomcat was not other fighters, but rather enemy missile bombers, such as the Soviet Bear. The Tomcat was designed to shoot down those bombers before they could launch their missiles at the carrier. Failing that, they were designed to shoot down the incoming missiles. This required the most powerful missile ever used on a U.S. aircraft, the Phoenix. It is the longest-range air-to-air missile in current service, as well as the heaviest and most powerful. The Tomcat's role is evolving to reflect a new security environment. Since the threat of Soviet missile bombers has disappeared, the Tomcat is taking on new missions. By adding sophisticated electronic attack systems, the Tomcat can now strike ground targets. Although no Soviet air threat remains, current generation Russian fighters are still quite capable machines. How good are they, and what impact will they have, as many third-rate air forces around the world purchase Russian combat aircraft as they appear on the world's arms market for the first time? Been more mysterious than those of the former Soviet Union, such as this MiG-29 Fulcrum. Cloaked under a veil of secrecy, it has long been a riddle how Russian fighter aircraft compared to their Western counterparts. But since the collapse of the Soviet Union, much more information has become available, much of it coming from the Russian designers themselves. Russia now operates two top-of-the-line fighters, the MiG-29 Fulcrum and the Sukhoi 27 Flanker. This is not a high-low mix, as in the American case, but rather is due to the different organization of the Soviet air forces. Technically speaking, the biggest distinctions between the Russian Fulcrum and Flanker are size and range. In order to patrol vast areas of airspace, the Flanker is an enormous fighter, similar to the U.S. Air Force's F-15. It has much greater range and payload than the smaller Fulcrum. The Fulcrum is roughly the same size as the U.S. Navy's Hornet strike fighter, and quite similar in performance. Of the two, the Flanker is the more impressive. It was designed specifically to match or surpass the U.S. Air Force's F-15 Eagle. As a result, it came several years afterward and incorporates some newer fighter technology, including fly-by-wire flight controls. It is also armed with an impressive array of missile weapons. The Sukhoi 27 forms the foundation of a whole new generation of Russian combat aircraft. Like the U.S. Air Force, the Russian Air Force is developing a strike version of the Flanker, the Sukhoi 34. The most advanced version of the Flanker, the Sukhoi 35, is still in development. It is being used as a test platform for several new innovations, including a vectored thrust engine for superior maneuverability. The Fulcrum is a smaller and less expensive fighter than the Flanker. It is the inheritor of a long tradition of Russian jet fighter design, including the MiG-15 fighter of the Korean War and the MiG-21 of the Vietnam War.
The MiG-29 was designed for very much the same kind of mission as an F-16. It has a lot of power and a lot of acceleration. On the debit side, as it were, the MiG-29's air-to-ground capability is not as refined in the current versions as the F-16s. The final and perhaps most serious shortcoming of the early version of the MiG-29 is it had very short range.
Although it has been assumed that the Russian Fulcrum and Flanker were simply copies of Western technology, new revelations about their design has cast these assumptions into doubt. Indeed, the Fulcrum reveals several unique approaches to design in the Russian fighters. For example, the matter of this strange bump on the nose of the Russian aircraft.
Well, there's a little tear-shaped blister at the, in the nose of a MiG-29 or an Su-27, which is called the infrared search and track system. And this is, it's essentially a terrific zoom camera, which enables the pilot to look far out, way beyond what the human eye could see.
As the veil of secrecy around Russian aerospace technology has lifted, we are finally able to take a more accurate measure of Russian combat aircraft. Pilot and aviation journalist Jeff Ethel recently had an opportunity to fly several of the newest Russian fighters and was very impressed.
These are phenomenal machines. They're built like tanks. They're built to have a 17-year-old maintain it with a ball-peen hammer. We can't do that. We can't even touch our airplanes without huge support facilities. So that's the first thing. They are rugged. They do fly. They do work. The second thing is they're cheap. They're much cheaper than ours, and they have the identical performance as far as speed, acceleration, power, all those things you want in a fighter. Are their radars as good? No. Is their avionic equipment as good? No. But do you need that extra last bit of Cadillac technology? Probably not. What you need is a well-trained pilot. And almost all studies ever since World War I have shown that the difference in a war is training.
Streaking over the skies of Europe, the sleek delta wing shape has become the symbol of French fighter design. While other countries have experimented with delta wing fighters, no nation has become so closely associated with the delta wing as France. This began in the 1960s with the design of France's most important post-war fighter, the Dassault Mirage 3. The Mirage was widely exported and became famous in the hands of Israeli pilots during the 1967 Mid-East War. The basic soundness of the design led to its continual evolution, including South Africa's version, the Cheetah. In the 1980s, the Mirage 3 evolved into an entirely new design, the Mirage 2000. Although similar in appearance to the Mirage 3, the Mirage 2000 took advantage of all the new fighter technologies brought about in the computer age, including electronic sensors, fire controls, and precision missiles. The latest version of the Mirage 2000 fighter, the 2000-5, employs a new generation radar and the Mika active radar missile. Although many fighter designers around the world consider the Delta configuration old-fashioned, the Dassault designers breathed new life into the design by incorporating computer-based fly-by-wire flight controls. Fighters with fly-by-wire controls are a dramatic improvement over those using conventional aircraft controls. On aircraft fitted with conventional controls, the stick and rudder are connected hydraulically to the control surfaces, which enable the aircraft to maneuver. In a fighter with fly-by-wire controls, there is no mechanical or hydraulic link. Instead, the stick and rudder commands are passed by electrical impulse to the control surfaces via computer. Fly-by-wire makes the fighter much more responsive and maneuverable. As has been the case with so many other air forces, the French have used their primary fighter design as the basis for a high-performance strike fighter. The Mirage 2000N is unique in this regard. It is not used for conventional attack, but as a strategic strike weapon for delivering nuclear missiles. In this role, the Mirage 2000N replaces the older and much larger Mirage strategic bomber. Fighter design has evolved quite differently across the English Channel. England has not designed its own fighters since the 1960s, with the English Electric Lightning. Instead, England has taken part in multinational European programs tied with Germany and Italy. In the 1970s, this European group, called Panavia, developed the Tornado strike aircraft. The Tornado performs the same role as America's F-111s or its F-15E Strike Eagles. It is primarily intended to attack ground targets, not for dogfighting. The Tornado formed the backbone of British combat aviation units serving in the Gulf War in 1991. Britain's Royal Air Force saw the need for a new fighter in the 1970s. Instead of following the usual practice of developing a strike aircraft from a fighter, Britain did the reverse, developing a fighter from the strike aircraft. The result was the Tornado F-3, also called the ADV, for Air Defense Version. In this role, the Tornado carries an advanced radar designed specifically for air combat. Instead of bombs and ground attack munitions, the Tornado carries the Skyflash air-to-air missile. The most remarkable fighter developed in Britain is the Harrier jump jet. The Harrier was not developed primarily as a fighter, but rather as a multi-purpose fighter and strike aircraft. It was designed to take off and land vertically. The idea behind the Harrier design is intriguing.
When the development of the Harrier was started, there was a great deal of concern about the ability of the Soviet Union to shut down NATO airfields. An airfield is a very big, totally immovable target. It has a lot of vulnerable points. It was felt back then that to have a few aircraft that weren't dependent on runways was a good insurance policy. And that basically was why the Royal Air Force got involved with the original Harrier.
This British idea proved popular with other air forces that had a similar outlook on the future of air combat. In particular, the U.S. Marine Corps became a firm supporter of the Harrier idea, and the Harrier has become the backbone of marine aviation. The Harrier has now gone through 2 generations of design. The latest version is the Harrier FA Mark II. FA is the abbreviation for the Harrier's missions, fighter, attack. This new version is fitted with an advanced radar called Blue Vixen. Whether over the skies of Europe, Russia, or North America, fighter aircraft are constantly being improved, thanks in large part to the revolution in electronics. But advances in electronics benefiting the current generation of fighters are not restricted to the fighter planes alone. Sleek nor fast, with speeds barely approaching Mach 1. They are called AWACS, for Airborne Warning and Control System. On the modern battlefield, what can be seen can be destroyed, and the AWACS can see electronically much better than any other aircraft ever developed. As we enter the age of information warfare, the AWACS has become not only the eyes, but also the brains of modern air battle, the computerized commander of the digital dogfight. In essence, Airborne Warning and Control System is an airborne command post. Air Force officers sit at consoles, monitoring the airspace around them for hundreds of miles. What has made this aircraft so important has been the advent of powerful computers. With all this digital information, the AWACS becomes the airborne brains of the dogfight. Like a coach, AWACS can pass instructions to each individual member of the team. They can tell them precisely where the enemy is located. They can tell them the best tactics to use. They can decide if the enemy aircraft needs to be attacked by 15 friendly fighters or only 1 or 2. The dogfight is no longer a contest of one-on-one, but a complicated team effort. Victory is decided by the team that has the best coach or commander. For nearly 7 decades, air combat has steadily evolved. In its early years, the accent was on improving speed and maneuverability. The classic dogfight pitted 2 fighters against one another, and the margin of victory was often a few extra miles per hour of speed, or a few extra degrees of turning ability. But the contest was decided by the gun, which had a range of only a few hundred yards. From the biplane fighters of World War I to the sleek aluminum propeller-driven fighters of World War II, speed and maneuverability were the ultimate technical capabilities desired by the fighter pilot. Recent innovations, like thrust-vectored engines, are being applied to today's fighters to enable them to achieve maneuvers that prior to thrust vectoring, they were incapable of performing. Thrust vectoring techniques vary. One method places paddle blades into the path of engine exhaust to direct the flow of engine blast. Another approach is multi-axis thrust vectoring. The key feature of a plane fitted with this type of thrust vectoring is the axisymmetric vectoring exhaust nozzle, or AVEN. The Avon can be fitted directly to the aircraft engine. Powered by hydraulic engine oil, 3 actuators drive the vectoring ring to allow multi-directional flow of exhaust. While severe angles up to 60 degrees per second can be achieved, computer software-driven flight controls allow no more than 45 degrees per second. This versatility gives the fighter maneuver capabilities that were previously impossible. The other approach to thrust vectoring is used in this advanced technology demonstrator, called the X-31. The X-31 was developed jointly in the early 90s by Germany and the United States to see how far fighter maneuverability could be expanded. By placing paddle blades in the engine exhaust and using advanced fly-by-wire controls, the X-31 achieves unprecedented maneuverability. Thrust vectoring enables the fighter to pull up to a 45-degree angle of attack, with the engine nozzles deflected upward to keep the fighter in the same plane of flight. Higher angles of attack, up to 60 degrees or more, can be achieved while remaining stable and maneuverable. The fighter can maneuver easily through thrust vectoring. It is able to move out of the plane of flight with no effort. Thrust vectoring not only increases the maneuverability of the fighter, but also increases its stealth characteristics, because, using its thrust vectoring, it is able to maneuver without its control surfaces moving. Hence, they do not deflect into the line of sight of a radar, giving the fighter's position away. The X-31 can perform maneuvers that would cause any other aircraft to lose control, or even crash. In mock combat against a Navy Hornet, the X-31 emerged victorious 80% of the time.
You can simply put the command into the stick, and it becomes more and more severe in its maneuverability. You can literally almost make a 90-degree turn. Unfortunately, the pilot can't take that. So we're really at the limits of what a guy inside can go through. Turn him into a puddle of wax. You just can't get him to do that.
This high degree of maneuverability is not confined to experimental aircraft. Russia has pushed the limits of the possible in its recent fighters, especially the flanker. By using advanced fly-by-wire controls, the flanker can be made to perform this incredible Cobra maneuver, literally stopping in space. This would cause nearly any other fighter to fall hopelessly out of control. In this maneuver, the fighter rears up on its tail, its nose high in the air. For a few brief seconds, no air flows under its wing, no air through its jet engine. This is the classic recipe for a catastrophic stall and loss of all flight control. The flanker avoids these perils by superb aerodynamic design and state-of-the-art computer flight controls. Although the Cobra maneuver is a remarkable air show demonstration, its usefulness in combat is open to question.
The classic thing that you don't do in a dogfight is anything that actually destroys your energy. And in the case of the Cobra, you come out of that maneuver in a very predictable, slow, level flight regime. So that you may use it to try and squeeze a shot off at one adversary who is then going to shoot straight past you. But if there's anybody else out there in the sky, you're low on speed and low on energy, and you're a sitting target.
But the importance of maneuverability in air combat is being widely debated. How valuable is maneuverability when an aircraft can be destroyed at long range by a missile before a dogfight will even begin? The most important revolution in aircraft weapons over the past decades is certainly the advent of the guided missile. Although missiles have been in use since the 1950s, the early missiles were plagued with problems. These early missiles, using tube electronics or unreliable transistors, could not withstand the brutal environment of high-speed flight. Their electronics were literally shaken to pieces, and when launched, often failed. By the end of the Vietnam War, new solid-state technology made missiles far more effective. Malfunctions began to lessen, and missiles began to dominate air combat. The first clear evidence of this came in the 1982 Falklands War, when nearly all the air-to-air victories were scored with new models of the Sidewinder missile. But the clearest hint of the future came in the same year during the war in Lebanon. The Israeli Air Force used Hawkeyes like these to serve as battle managers for the fighters. Their long-range radars detected Syrian fighters from dozens of miles away. As a result, the Israeli F-16 fighters engaged the Syrian fighters from more than 20 miles away with Sparrow radar-guided missiles. The Syrian squadrons were decimated before they could even fire their own missiles. One of the most impressive features of current Russian fighters is the latest generation of close-range dogfighting missiles. This missile, called the R-73 by the Russians and codenamed the Archer by Western intelligence, is widely regarded as the best in its class in the world today.
When it appeared, it came as an enormous surprise to the West, because here was a highly agile missile. It beat the pants off Sidewinder, and it also was a big weapon. It could knock down just about any target that was out there. The West had nothing that was comparable to this at all.
Finally, the true importance of missiles became evident in Operation Desert Storm. Hardly any Iraqi aircraft were shot down by gunfire. Instead, the vast majority of air-to-air engagements were at very long ranges, using radar missiles. Suddenly, the lessons of the Vietnam Air War were completely rewritten. The classic dogfight of swirling fighter planes locked in deadly one-on-one combat was disappearing. Air combat now takes place at vast distances, often at ranges where the enemy cannot even be seen with the human eye. Accurate long-range missiles may cause more than the extinction of the visual dogfight. Fighter aircraft must find a way to survive against such deadly weapons. Today's combat aircraft employ new technologies to do just that, survive and win the digital dogfights of the next century. The dominance of radar command and control and radar-guided missiles led fighter designers to consider different approaches to aircraft design. How could electronic sensors and the radar-guided missiles be defeated? Electronic jamming was attempted, but was only partially successful. In the 1980s, designers began to examine whether an aircraft could be made virtually invisible to radar. This new design is called stealth.
Stealth is a series of measures designed to make it as difficult as possible to detect and, more importantly, to track during an engagement sequence. There is no way of making a piece of equipment invisible. What you're trying to do is to make it as difficult as possible for your opponent to track it and engage it. A stealth aeroplane, the B-2, the F-117, are detectable. What makes it difficult for the opposition is that they can't track it.
The first aircraft of this kind was the F-117 stealth fighter. The term fighter is a bit of a misnomer. The F-117 is in fact a strike aircraft designed to attack ground targets. Its primary weapon systems are laser-guided bombs. The F-117 first proved the stealth concept and was followed by a second generation of stealth technology, the B-2 Spirit strategic bomber. The problem with stealth for fighter planes is that much of its effect comes from shaping the aircraft to reflect radar waves away from the enemy. These exotic shapes do not make a great deal of difference in bomber design, since there is not as great a need for speed or maneuverability. But fighters still need both speed and maneuverability, even in the missile age. Incorporating stealth features in fighters requires sacrifices in their performance. As a result, the next fighters to come online have been designed with a compromise in mind, searching for as much stealth capability as is possible without hindering performance. The first serious attempt at a true stealth fighter is the F-22 Advanced Tactical Fighter. Stealth requires important changes in design. For example, all of its missile armament must be carried internally, since externally carried missiles are too visible to radar. The main attraction of stealth fighters is that, in theory, it should be nearly impossible for the enemy to target such a fighter, unless they meet at close range. This gives a fighter with stealth characteristics the ability to fire many of its long-range radar-guided missiles way before the enemy fighters can even detect its presence. The F-22 has the most stealth features of any new fighter.
Developing stealth technology was a phenomenally expensive effort, I believe. We don't know because they were black programs and there's still much to come out of it. But I would think overall that the US has probably invested as much in stealth or low observability technology as it did in getting to the moon. Now, not every nation is it can afford that.
Still, many countries are not convinced that stealth is worth the trouble or the expense. But designs, such as the French Rafale, incorporate some stealth features. The Rafale is configured to reduce its visibility to radar without the need for the extensive structural changes and design compromises of the US F-22. This reduces its price tag compared to the American design.
What stealth absolutely isn't is a sort of single magic ring that you put on and makes you invisible. It's really more a goal. It's a set of requirements that you can design your aircraft to just as you design it for a given speed or range or weapon load.
For other European air forces, stealth has proven too expensive. The new European multinational Eurofighter has very limited stealth features due to cost problems. Instead of adopting stealth, the Eurofighter designers are developing a new generation missile, the Meteor, to enable fighters to strike enemy aircraft at ranges of over 50 miles, ranges inconceivable a generation ago. The top Russian fighter, the Sukhoi 27, and its latest version, the Sukhoi 35, seen here, have no stealth characteristics at all. The Russian Air Force was forced to abandon their own stealth fighter due to a lack of funding. The reality is that modern fighter design has become so expensive that few countries are able to afford even the non-stealth fighters. France's Rafale fighter has been plagued by funding delays, which stretched out its production and threatened to dramatically increase its cost. Some French officials have pushed to halt Rafale production for a decade, buying the older Mirage 2000 in the interim. A new version of Rafale with more stealth characteristics could be bought a decade from now. Originally planned to be half the cost of the US F-22, Rafale may end up being more expensive, even without full stealth features. Eurofighter 2000, being developed for the British, German, and Italian air forces, has been delayed so often by budget problems that there is the real possibility it too will end up being more expensive than even the F-22. Budget battles, rather than air combat, are now the new fighter's greatest enemy.
It won't print.
Fighter design. The JAS-37 Gripen represents a combination of the latest in weapons and electronics technology minus stealth. The Gripen will be armed with a highly effective AIM-120 AMRAAM missile, imported from the United States. Later versions will employ the new Meteor missile, being developed in cooperation with Britain. The Gripen's powerful radar, combined with its missile armament, enables it to engage targets at ranges of over 50 miles. This balanced approach, combining the best in electronic sensors, airframe design, and advanced weapons, is likely to be more typical of fighters in the early 21st century than stealth fighter designs. Still, side by side, the Gripen does not measure up to the Eurofighter or Rafale. But this is not an indication of a lack of sophistication. In fact, the Gripen is just as high-tech as its European contemporaries. Rather, its design, namely its small size, reflects political and security considerations. All airfields in Sweden are very close to its borders.
Also, it's because of uncertainty. You don't know who your enemy is going to be anymore. You need to put as much capability into your platform